In this video, we're going to be factoring perfect square trinomials. The way we identify perfect square trinomials is by looking at, first it must be three terms, hence the trinomial part, and the first term and last term must be perfect squares. So m squared is the same thing as just m being squared, and 16 is 4 squared, so this is m squared and 4 squared. If the first and last two are perfect squares, and when you take what is being squared, so in this case the 4 and the m, multiply it together, so that's 4m, and then double it, so 4m doubled, and you get the middle term, then that is a perfect square trinomial. And there's a shortcut method to factoring. So looking at this, we see the m squared, the 4 squared, put the two together, the 4 and the m, and then double it, we get the 8m, which is in the middle. So I can go straight into factoring. So the original was this m squared minus 8m plus 16. And it's going to factor into what these terms were. So the m was being squared and the 4 was being squared, and since the sign in the middle is negative, this will be negative, and it will be that binomial squared. And you can always check this by rewriting it as m minus 4 times m minus 4 and then multiplying it out. So we'd get m times m would be m squared, negative 4m, negative 4m would give us the negative 8m, and then negative 4 times negative 4 would give us the positive 16. So notice that this is the exact same binomial being multiplied by itself, so it is being squared. Hence, we write it this way. If you have a term being multiplied by itself, you can write that whole binomial is being squared. Same thing down here. So I look at the first term, 4h squared. That's the same thing as 2h is being squared. 2h times 2h would give us 4h squared. And the last term is 1 squared. If we multiply these two things together, we'd get 1 times 2h, or just 2h. And then double it, that gives us the middle term, 4h. So again, this is a perfect square trinomial. And when I go to factor it, oops, there's a 4 there. I know it's going to factor into 2h times 2h gave us the first term, and the middle term was positive, so this is going to be positive, and 1 times 1 gives us 1. And then take that binomial and square it, and that would be the 4h squared plus 4h plus 1. Again, you could expand it out and multiply to check yourself. So, in summary here, we've got these two equations that you can memorize. And it's just saying that if I have a perfect square trinomial, notice here we have the first term is squared, the last term is squared. You put those two things together, a times b, and then double it. It factors into the first term plus this last term, that whole quantity being squared. Now it's not a squared, it's not the whole a squared, it's just a, what is being squared, or you could think of it as the square root. So m squared, the square root would just be m. 16, the square root would be 4. So that's where we get our a and our b. If the sign in the middle is positive, the sign in the middle here is positive. If the sign in the middle is negative, the sign in the middle here is negative. So go ahead and try these two, and notice I have this be careful here. Think about what you should do first in any factoring. Alright, let me get a different color here. So we look, we see that the first term is a perfect square. This is the same thing as 8m squared. The last term is a perfect square. 1 times 1 would give me 1. And when I put these two things together, 8m times 1 would be 8m. And if I double it, I would get 16. So this is in fact a perfect square trinomial. I can factor it straight into my squared binomial by taking the square root of the first term. So 64m squared, we already said was 8m. Square root of the last term, the square root of 1 is 1. And I know the sign in the middle is negative, so the sign here will be negative. And that's as far as we can factor this. Same thing down here. Only, I said be careful, because there is a GCF on this problem. There hasn't been one yet. There's nothing that has been in common in all three terms, but this one does have a GCF. I can take out, let's see, a 4 and an x. So when we take out the 4x, we are left with 16x squared. 32 divided by 4 would be 8. We're dividing out 1x. Still have the y. And 4x divided by 4x would be 1. So we're just left with that y squared. Alright, so we've got the GCF here. But now we want to know, can we factor the rest of this here? So again, we have to check to see what we're dealing with. This is a perfect square, 16 is a perfect square, and we have x squared. And we have y squared, that's a perfect square. So what makes up 16x squared? Well, square root of 16 is 4, square root of x squared is x. So that quantity squared would give us the 16x squared. Square root of y would be y, and then we square that. If we put the two terms here together, 4x times y, that would be 4xy, and double it. And that gives us the 8xy. So this is a perfect square trinomial. So I go into factoring. I don't forget my GCF. I know I was going to factor into a squared binomial. And the terms are going to be the a, so 4x, and the b, which was y. Remember, we got that from taking the square root. So square root of 16 was 4, square root of x squared was x, square root of y squared was y, and the term in the middle was negative, so my sign here will be negative. And that is completely factored. So always, always, always start with your GCF. Now keep in mind that I have used this shortcut here. If we recognize a perfect square trinomial, we know exactly how it's going to factor. But you do not have to memorize that, because you can always factor these the way we did previously with trinomials.